In a dockyard, the size of a large airfield, an army of engineers is building a ship like no other.
This is the most demanding job ever.
Longer than 4 football pitches and capable of carrying more than 18,000 containers. It's the world's biggest ocean-going cargo vessel, the Triple E.
We have a major challenge to get the 2 first vessels completed in time.
They have just 38 weeks to build and trial this monster.
If the propeller falls off or something, I lose my job.
Safety is a disgrace. You have open gratings, you have hoses, cables obstructing the routes.
This is the exclusive inside story of the men and women racing to build the world's biggest ship. Okpo, South Korea. And in the world's second largest shipyard, an enormous vessel is taking shape. One that could change the shipping industry forever. The Triple E. 400 meters long, the Triple E will be the world's biggest ship. A steel leviathan powered by 2 enormous engines, each capable of delivering more than 40,000 horsepower. Enough power to carry 165,000 tons of cargo at a steady 16 knots halfway around the world. The man tasked with delivering this mega ship on time is site manager Søren Arnberg.
Of course, we hope it will go as smoothly as possible, but we will have challenges, and sometimes maybe big challenges during the construction of the 2 first vessels.
Søren leads a team of 24 inspectors drawn from around the world.
We have assembled a crack team, yes.
The odd shaft has just been inserted.
We are getting somewhere. We're getting forward.
The vessel's enormous hull is almost complete. Next task: install the ship's vast engines and propellers that will power her through the ocean. They've been conceived here, at the headquarters of Danish shipping giants Maersk Line, by naval architect Troels Posberg. He's designed hundreds of vessels in his 32-year career, but the Triple E is a different beast.
Of course, I'm getting emotionally involved in these vessels because I'm part of their design and they are part of me. It matters a lot to me, and not only to me, I think it matters a lot to everybody in this company that these ships perform. The design of the propeller is of course important. We need to have an efficient propeller.
But Troels' plan for the ship's propulsion system is highly unorthodox. His design for the Triple E will not only make her bigger and heavier than her competitors, but also more efficient. Powering the ship with a single engine would need a huge propeller. But a propeller this big would break the surface of the water, making it ineffective and wasting energy. So Troels is splitting the power between 2 engines, driving 2 smaller propellers. This design should maximize efficiency, but is a first for a container ship this size.
We Having one massive propeller would not provide you with the most optimal solution.
Trolls has also opted for 4-bladed propellers rather than the usual 5 or 6 blades.
I guess my reputation is on stake in the design of this vessel, so we will see if they perform in the final end.
The first challenge facing Trolls and his team is actually making the propellers themselves. He's on his way to Waren in Germany, where they're being cast.
The casting process is so essential. If the casting goes wrong, you'll get delayed and you will have to catch up.
This vast foundry has the world's biggest electric furnace, making more than 200 ship propellers every year. Trolls is meeting factory boss Manfred Urban.
Oh, hello, Trolls. Good morning.
Morning. Guten Tag.
How are you?
Good to see you. I'm looking forward to this very exciting day. How much load have you put on the mold here to keep it?
500 tons?
500 tons? That's a lot.
Casting the Triple E's propellers presents a major challenge, even for Manfred's team. As molten metal pours into the propeller mold, tiny hydrogen bubbles form cavities as it cools. These could spell disaster for the ship. That's because as a propeller spins, extreme pressure is put on the blades. Powerful enough to fracture any holes created by the bubbles, forming cracks, which could wreck the entire propeller.
During operation, we have to make sure that there's no reason for cracks or whatever. Casting is the most sensitive period in the lifetime of the propeller, because all the mistakes you do during the casting, you cannot rectify. And it's very eager to get hydrogen inside the alloy. And we have to make sure that this hydrogen is coming out before we cast.
To do this, Manfred's team will use an ingenious chemical technique. They will pump argon gas into the liquid metal to remove all of the hydrogen bubbles.
This argon gas on its way from the bottom of the furnace to the surface. Whenever it will meet some hydrogen gas, it will take it away.
You don't want any cavities inside the alloy after it's casted.
With the bubbles gone, the team gets ready to pour 115 tons of liquid metal into the mold.
Yeah, now we are ready.
We cannot interrupt the casting. Once we start, we have to finish it.
It's now or never. That is really amazing, this one here. I've never been that close to a propeller manufacturing. Perfect. Dramatic. Excellent.
Guter Job, Dankeschön. Alles klar. Gut. Danke.
It takes 11 days to cool the propeller before it's shaved down to size by a team of robots. After a final buff and polish, the propeller, worth $1 million, undergoes a crucial test.
scan the surface of the propeller. After the scan, we can see it on the computer, is to make sure that the shape is perfect.
It takes 8 hours to map every last millimetre of the giant propeller's surface, looking for the slightest defect.
It's important to see what the condition the propeller is. You can see it on the screen. All is fine for the moment.
There's very good, no defects found.
Propeller number 1 passes the test. A final once-over from Trolls, and he can sign it off.
The first propeller?
Yeah,
Tripoli?
that's the first baby. It looks very nice. We are planning to dispatch these propellers next week to Hamburg port, and then it's on the way to Korea. Yeah?
Here you are.
Thank you very much.
Congratulations.
Thank you.
Thank you.
Thank you.
Okpo, South Korea. With the first of the Triple E's twin propellers cast, workers at Daewoo Shipbuilding and Marine Engineering are preparing the vessel's engine bay for the arrival of her giant power plants.
Without the engine, the ship would just be a big barge.
Straight-talking machinery master Stephen Murdoch will oversee the installation of the engines.
The engine is like the internal organs of a human being. Everything's got to function together.
Since switching from sailing ships to building them, he's constructed more than 40 vessels.
26 years I've been at sea, okay? I am very experienced.
He has a keen eye for detail, and he's worried the engine bay is far from ready.
This defect tag for the misalignment was put on at the beginning of December. Nothing's been done.
This is a little bit more of a challenge compared to a single-engined vessel. We've got 2 engines, so basically we end up doubling up on the majority of the equipment.
Each engine costs $5 million and is the size of a house. Built from more than 60,000 components, they are the most complex parts of the ship. And before being installed, they're getting fired up for the first time.
We want to make sure that we get the highest quality engine from the maker. We don't want any problems.
The man Stephen is banking on to deliver the perfect engine is Jens Otto Munk.
We call it job test. It is a complete test of the engine. Hopefully we will have no problem. It will go smoothly.
Jens's team uses a unique piece of kit to max out their machine. At sea, water pushing against a propeller's blades puts the engine under immense stress. To simulate these forces in the factory, technicians connect the Triple E's engine to an ingenious invention, the water brake. It's a giant rotor blade which takes the place of the propeller and is sealed inside a huge steel drum containing water. Workers adjust the level of the water to push the engine load to the limit.
The load test will start with 25% load and then load up to 110% load. It's the first time and the last time we will have 110% load on the engine. It will not happen again. Engine is ready for start. It's looking good. At the moment we are here 90% load.
But just as they crank up the power, there's a problem. At the very top of the engine, a technician has spotted something that could spell disaster. An oil leak.
It can make the big problem, like the fire, like the explosion.
Jens puts the test on hold, while the technicians locate the source of the leak.
We are looking for which point is leakage, such as the fuel oil pump or injection valve.
They trace the leak and seal it up.
After solve this problem, we will run this engine.
The team fire up the engine for a second time, increasing the power and pushing the brand new engine to its limits and beyond.
Now engine load have been raised to 110%, which is an overload test.
The tension is visible.
Engine speed 18.2. Turbocharger number 1 2830. Number 2 2825.
So everything going smoothly. Thank you very much.
Thank you.
So finish shop test. It performed well. Next up will be DSME.
They will send us a full report of the shop test. It's a little bit exciting then. We can get on with the installation of the engines on board the ship once they arrive here.
Back in Dock 2, as the Korean crew prepares the engine bay, site manager Soren has some safety concerns.
Jane have cables and hoses blocking the route. Then probably have a slip accident. We have a clause in the contract that we have able to stop the work, get all the workers out until we have cleared what we have pointed out have been corrected. Then they're allowed to work again.
While he's reluctant to pull the plug on the build, Soren has to make sure things improve.
The cables are blocked by welding cables and hoses. They need to clean up so it's not a mess, so we can find a way around.
Meanwhile, in Germany, a specialist crew is getting ready to transport the first propeller to Korea. Costing a cool $1 million and machined with mind-boggling precision, hauling this precious load almost 300 kilometers to the port will be no mean feat.
A great day for the propeller, a great day for us after we worked so many weeks to finish this propeller.
Wolfgang, hörst du mich?
Today we have to say goodbye on one side, but on the other side we can expect to get the money soon. That is also very important.
Let's go.
It's a tight squeeze through this tree-lined trail.
Okay, links. Rechts okay, ganz rechts kommen.
This is the riskiest part of the journey. The slightest lapse in concentration could lead to a big repair bill for truck driver Jörg Mehlhaas.
Lecker! Ein Schwein, ja, ein Pork.
Und Schmetterling.
Jetzt kommen wir gleich auf die Autobahn.
After a grueling 6-hour trek, Jörg arrives at the port of Hamburg.
No problem. Wir sind angekommen.
Lowering the propeller into the ship's hold needs a delicate touch.
We could have a sudden wind that could blow the hook away, and it could hammer at the side. That could damage the propeller. People could get hurt. It's quite dangerous.
The 70-ton monster hangs precariously in the balance.
It's huge, man.
Touchdown. Finally, the propeller can leave for Korea. The next time it sets sail, it will be powering the Triple E on her maiden voyage.
It's a thumbs up. Next stop, Korea.
In Okpo, South Korea, work continues on the 60,000-ton ultra-large container vessel, the Triple E. With the first of our giant propellers en route from Germany, Søren Arnberg and his team are preparing to install the engines that will turn them.
We have the erection of main engine taking place in this week, in fact. We will also have the shafts in this next week, so it will be quite a busy week.
Before work begins, Lead Machinery Superintendent Stephen Murdoch carries out a surprise inspection.
There are a huge number of pipes to inspect.
And he's not happy.
The protection of the pipe has been broken. We're preventing ingress of dirt and foreign materials into the pipe. This is a defect tag. They will sort it out. And we'll follow up and check that it's been sorted out.
With more than 100 kilometres of pipework throughout the Triple E, Stephen knows that there's very little chance of discovering blockages at a later date.
This is a good example of why we do surprise inspections, because we find something like this where pipe has been used as a storage facility. Well, if this equipment, if it's left in here, it will go through the system. It could either cause damage to valves, it could cause damage to pipes, it could cause blockages. It could be a disaster. And they will now remove it and clean the pipe.
Before installing the engines, Søren is keen to discuss his safety concerns with the yard.
I would say your safety, household keeping is a disgrace on board 4250. You have open gratings, you have hoses, cables and everything obstructing the route. So if you're not seeing improvement, latest by Monday, we will stop your work. Then you have a holiday. No, but we need to improve this one.
It's very important.
Yes, it is.
Very, very.
Yes.
After Søren's ultimatum, the installation of the propulsion system hangs in the balance. More than 2 years of research have gone into designing the Triple E's propellers and testing all aspects of their design. Trolls has been keen to avoid one problem that has blighted propellers for over 100 years: erosive cavitation.
You can easily design a propeller that is very efficient, but it might then also have a very bad cavitation pattern.
As a propeller blade slices through the water, it creates an area of extremely low pressure. This causes the water to vaporize, forming tiny bubbles. As the bubbles burst, they create powerful shock waves, tiny pinpricks of energy capable of damaging even the hardest of metals. Over time, this effect, called cavitation, eats away at the propeller's blades, rendering them useless.
And that's, of course, critical. We don't want to lose the propeller because of erosion or cavitation.
And so several months ago, Trolls booked a crucial test at this $20 million facility, home to a state-of-the-art cavitation tunnel, run by Martin Gooch.
It's like a wind tunnel, but from marine testing, we increase the water speed inside the tunnel and test the cavitation behavior of the propellers.
On trial, Trolls' unorthodox four-bladed propeller design. First, he and Martin tested a five-bladed design for comparison.
Are we up to the full speed now?
We have full speed condition.
It sounds noisy. I'm a little bit concerned, so maybe we should put on the strobe lights.
Yeah. We hear the cavitation and now we see it.
We'll feel it as vibrations in the ship. So.
Yeah. The cavitation can be very aggressive. The propeller will melt.
We cannot completely avoid bubbles, but the erosion cavitation is completely unacceptable.
Trolls' four-bladed design had to perform better.
Yeah, this will be the moment of truth. We have an expectation, but we don't know before the test. This is very different what we saw with the five-blade propeller. The amount of cavitation is smaller and that's a good result.
Unlike the five-blade propeller before it, Trolls' four-bladed design passed the test, much to his relief.
I think we have found the right propeller.
Yeah, take this one.
Yes. Price for a propeller, yeah, more or less $1 million. But we've been waiting for this design here in 2 years. I think it has really paid off.
Today, back in Korea, the Triple E's engines are finally ready to be lowered into their bays. But for Stephen and his team, installing a machine the size of a two-storey house is a Herculean task.
The main engines have been completely built up at the factory and they've been tested there. Then for transportation and for fitting into the vessel, they've been disassembled.
Weighing in at around 1,300 tons apiece, the engines are too heavy to lower into the hull in one go. So the team will install them in 3 parts, lowering each piece down through an opening in the engine room, barely wider than the engine parts themselves. The stakes are high. If one of the sections collides with the ship on the way down, the damage to the vessel and engine could be catastrophic.
The engine will be lifted in a number of sections and will be built up. The complete rebuild of the engine will be closely monitored. All the sections will have to be very carefully aligned.
With so much at stake, Stephen entrusts the job to one of the yard's most extraordinary machines. The mighty Goliath crane. Standing 100 meters tall, its 96 wheels roll down steel tracks running the length of the dock. It's the king of cranes and can lift up to 900 tons. At its controls is Kim Sung-hoon.
예, 처음에는 좀 겁도 했는데 시간이 지나다 보니까 지금은 좀 편안합니다. 작업을 하는 시간만큼은 다른 데 신경 쓰지 말고 딱 신호수가 요구하는 것, 그리고 제 손에, 그리고 제 눈에 항상 집중을 해야 되겠죠. 지금 대우조선 해양의 골리아스 크레인은 현재 배를 건조하는 생산에 가장 제일 정점에 서 있고요. 지금 저희 크레인이 만약에 움직이지 않는다면 지금 배를 만들 수가 없겠죠.
100 meters below, workers connect the Goliath's cables to the first engine block, known as the bed plate.
지금 세팅을 했을 때 최대 3mm까지 맞출 수가 있습니다. 기본적으로 크레인이 물건을 물고 있을 때 사람이 밑에 가는 그 행위 자체가 위험한데, 근데 그 작업 특성상 그 크레인이 물건을 들고 있는 그 밑으로 사람들이 서 있기 때문에 저희가 혹시나 실수할 수도 있는 부분이고, 혹은 그 작업 과정에서 사람이 다치게 된다면 아주 중대 사고로 이어질 그 소지가 다분해서 그래서 위험합니다.
Sung-hoon's eyes on the ground is foreman Lee Sung-hee.
주행센터 맞춰보세요. 주행센터. 이 이제 수미, 선수, 선미, 이 어떤 갭 상태, 간섭되는 걸 피하기 위해서. 간섭. 이 이제 이래 장애물 간섭이에요. Okay.
The bed plate slowly begins its descent down through the hole in the engine room.
남쪽 인칭. 제거해가야죠.
With the bed plate dangling just above the drop zone, they hit a major snag.
한번 같이 당기고.
The hole through which the giant engine must fit is too narrow. Sung-hee's team must act fast.
이제 이걸 철거하고 나면 이제 다운 시켜가지고 이제 제자리 이제 이 메인 엔진이 이제 배에 이제 인간을 이야기하면 심장이지 않습니까? 조금이라도 데미지 가면 충격이 크니까 아주 이제 데미지가 안 가게 아주 미세하게 작업할 수밖에 없습니다.
They pull, bend, and cut away at the obstructing steel. Until the engine block squeezes through.
Okay, we've just lifted in the port main engine bed plate. You're starting to get a scale of the actual size of the engine room, which is very big on this vessel. Everything coming together, it's always amazing.
But the struggle to install the engine has come at a cost. Cutting space for the bed plate has made a mess of the engine room floor, throwing up even more safety issues.
Found out that safety is no good. You can see here there's a big opening. This will help you nothing. You need steel barriers, like the handrail, going along. This helps you nothing. Yeah, pipe all the way around here. They're hard at work.
Mindful of Soren's threat to stop production, the workers rush to erect a handrail.
Your responsibility. Good, thank you.
After 5 weeks at sea, the first of the EE's $1 million propellers finally arrives in Korea. Before it can be installed, Hull Superintendent Peter Bertelsen carries out a critical inspection of the ship. If safety hasn't improved, Peter's boss Soren will have to halt production.
Normally we go around the engine room, have a look if it's okay. This is a working place. It's not a desk where people are sitting shuffling paper around. People are welding, people are cutting. It is a dangerous workplace.
One hour later, Peter delivers his verdict.
They're doing a very good job. Safety has gotten better on board, no doubt. It was very cluttered and very dirty, and there was materials all over, and they were bad at fitting handrails, so, but they are getting better. It looked good, no problem.
You can see the had changed attitude in the safety. It looks very clean now. Everything is nicely coiled up and is clean.
The team is given the green light to lower the last engine block into place and fit the 280-ton shafts that will connect the engines to the propellers, giving them a good greasing. It's now the propeller's turn.
The crane will be attached to the top of the propeller by an eye bolt. Because of the design of the propeller, that's the only way that we can lift it. Being on a single point lift, if it does start to swing in any way, then it's more difficult to control. Damage can happen if something goes wrong.
It's down to crane operator Kim Sung-hoon to thread the propeller onto the end of its shaft. The lift is on.
프로펠러 작업이 코를 하나만 차고 가기 때문에 어떤 블록 작업보다 어떻게 보면 더 미세 작업이고 또 위험하다고 할 수 있죠.
예, 아주 섬세하고 민감한 작업입니다.
맞는다 이거.
예, 뭐 샤프트에 데미지가 간다든가 아니면 프로펠러 자체에 데미지가 손상이 갈 수가 있습니다. 데미지가 갈 수 있습니다.
Suddenly, Sung-hoon's worst fears are realized as the propeller begins to swing. Sung-hoon must regain control fast. Or the propeller could smash into the shaft. At last, the team brings the propeller under control. And with a reassuring bomb, it comes to rest on the shaft. But not everyone is happy.
This is nuts on. What is going on here?
Steve.
It turns out someone forgot to tell Stephen of the lift.
I was told Thursday we put in the propeller on.
Yes. Thursday. Yeah, but our schedule was changed because of the crane schedule.
I haven't watched you put in the propeller onto the cone. I do not know if you've damaged the cone while you've been putting it on.
With Stephen insistent on checking that it's been properly attached, the build team has little option but to remove the propeller and start all over again.
Not very happy at the moment.
You want to check the inside of the propeller?
I want to check inside the propeller. I want to see you fit in it. Problem with the propeller falls off or something, I'll lose my job.
Also, we lose all our jobs.
This is an important inspection because it's only the contact, the friction between the shaft and the propeller hub that is holding the propeller on.
The propeller is removed, enabling Stephen to carry out his checks.
It's looking good. Yes, we're all happy again.
With Stephen now satisfied, the crew can fit the propeller for the second time.
They are going to be the biggest container vessels in the world, and we want to make sure that the vessel is delivered satisfactory without any problems.
With both its engines and propellers in place, the first of Maersk Line's new breed of mega container ships, the Triple E, takes another giant leap towards completion.
The main engine's been put in. We've reached a major milestone. Now, the heart of the ship is in place now. Now we've just got to get it started.
But the mission is far from over.
Had to be perfect. We're not giving up before it's perfect.
As the team battle to install the ship's towering superstructure.
This will be one of the most important rooms on the ship.
And the race to build the world's biggest ship continues.